So for continuing the improper integral notes, we're doing example 3. 1 and 2 were on the other video. So example 3 says that we're evaluating the integral from 1 to infinity of 1 minus x times e to the negative x dx. So why is this improper? It's got an infinity. Marvelous. Yeah, so that upper bound is infinite. That's a problem. So what did I typically do when I approach the problems in the video? What did I do first? I integrated it. I just knew, like, I can't plug the numbers in, but I can integrate it. When you guys look at this, does it remind you of anything? Like, what type of method could we use to integrate this? It's an integration by parts. Why is it an integration by parts? It's got 2 parts. Yeah, you can see it. It's got 2 parts. It has the 1 minus x and it has the e to the negative x. It's got 2 different parts. So remember, we have to remember the acronym LATE. We also have to remember that anything that looks like a polynomial could do the chart. So is this one where we use the acronym LATE? Are you goofing off right now while I'm making a video? James Betts, whose mother will receive this video. Thank you, James Betts.
I didn't do anything.
I mean, your face looks a little guilty right now. All right, so 2 parts. Are we seeing that we need to use the acronym LATE, or are we seeing that we have a polynomial somewhere in there? We got a polynomial. What's the polynomial? It's the 1 minus x. Is that a polynomial? It's a very simple one. It's a binomial, but it's a polynomial. It's got 2 parts, right? We've got x to an exponent. So I'm going to go ahead and start making my chart. I've got the sine. I've got the u. I got the dv. So my u is 1 minus x. What's the derivative of 1 minus x? Negative 1. What's the derivative of negative 1? 0. Okay. And then that makes it so my dv is e to the negative x. And what do I have to do with that e to the negative x? You have to do u substitution. We've got to integrate it, right? So e to the negative x dx. If I was to integrate that because that x is negative, this is a u substitution problem. So I would say u is negative x. That means that du is what? Negative 1 dx. We do not have a negative in the problem, so what do? Yeah, divide by a negative. So I'm going to put a negative out in the front, and then I'm taking the integral of e to the u du. And so what do I get for that? Yeah, so negative e to the u. I guess that'd be a plus c, but I won't write it. And then I can go ahead and take my u and replace it with the negative x. So I've got negative e to the negative x. So if I'm integrating negative e to the negative x, if I'm integrating negative e to the negative x this time for this part, then I can just take the negative and put it in the front. And what was the integral of e to the negative x? Yeah. So we've got the negative version of negative e to the negative x. And that makes it positive. Okay, so positive e to the negative x. So those would just repeatedly alternate signs over and over. Right, James Betts?
Yes. Please don't send us.
All right, so what is our integral? Yeah.
So basically, for any other situation, I could just multiply whatever I have to the derivative of x. Because right there we did e to the negative x. We just multiply the times the derivative of x.
Yeah, well, most of the time, so this, because the derivative happened to be negative 1, that's why I alternate signs. Remember, if it's a number, it would usually be a fraction out front. Like if it was e to the 2x, and it would have been 1/2 out front the first time, and then that 1/2 would have stayed, and then another 1/2 would have gone, it would be 1/4, and then 1/8. Yeah. And that's why I always do my work off to the side, because that helps me just not make mistakes. I just don't do it in my head. Yeah.
I was just trying to see if I can make that jump.
Yeah. No, not quite. Those numbers.
I tried.
Yeah. It was a good try. It was a good try. All right. So, what do we have for our integral? So I'll just say that this is negative of 1 minus x e to the negative x. And then what do we have? Oh, plus e to the negative x. Okay, and these this is being evaluated from 1 to infinity. And this is the part where we say, oh, silly, you can't plug infinity in. So make it a limit, and then you can plug infinity in. Silly rabbit. So now we're going to say the limit as c goes to infinity. And we're going to use the same thing, because it's okay if it's a limit. I'm going to go ahead and write this as 1 over e to the x. Are you guys okay with me doing that?
Yeah.
Does anyone know why I did that?
Negative x.
Yeah, it's a negative exponent, and then it's a little bit easier to see what's going to happen.
Hey!
Hi.
She was in the class.
All right. I made a typo right here. Instead of infinity, put c.
Yeah,
Yeah, sorry about that. As c goes to infinity, so it should be from c to 1. All right. So now I can go ahead and plug it in as long as I'm plugging in a c, not an infinity, technically. So I've got negative of 1 minus c times 1 over e to the c plus 1 over e to the c. That's what I get when I plug the c in. Minus negative 1, nope. My negative went in the wrong spot. All right, minus, and then the negative goes in the front. 1 minus 1 times 1 over e to the first power plus 1 over e to the first power. Okay. So if we think about the c as being an infinity, e to the infinity is going to be infinity. So what does this fraction basically equal? 0. 1 over infinity is 0. So that means that this whole term just got wiped out. So we're going to say that term is 0. Right? And then what's this other term right here? 0 for the same reasoning. Okay, so there we got 0. Minus 1 minus 1 is 0, so this whole term gets wiped out. What about this term over here, 1 over e to the 1? It's still just 1 over e, or 1 over e to the 1. You can still write it like that. So we would say that this converges, right? We have an actual answer. We didn't have, none of these were unlimited, like we didn't have infinities for any of those, so all those limits were able to be evaluated. So it converges, and what does it converge to? Negative 1 over e. So all the zeros we're ignoring, but we got this negative, and then we got the 1 over e. So we're going to say negative 1 over e, and we're going to say that it converges. And when I say it converges, what do I mean by it? What am I finding? It's an integral. But what's an integral? What's that mean? The area under the curve is converging to negative 1 over e. That's what it's converging to. All right, let's do one more. Last example, example number 4.
And if I did, then I would just write that.
All right, so this one, we're evaluating the integral from 0 to 1 of 1 over the third root of x. And I do not like having radicals in my problems, and I don't like any type of exponent that's on the bottom. So how could I rewrite this? X to the negative 1/3. Okay? Why is this an improper integral? Because, yeah, you can't plug in 0. It's undefined at 0. All right. So let's go ahead and integrate this. How do we do that? Add 1. Sorry, that's very small. Let me zoom out. Sorry.
Sorry.
You guys were all squinty, and I was watching you squint, but I was just letting it go.
Oh, wow.
It's like, I'll just keep saying it out loud real slow. And I was like, no, you can zoom in. Right, James Beth? Alright, so negative 1/3 plus 1 is 2/3 divided by 2/3. So what is our integral?
3/2 x to the 2/3.
Evaluated from 0 to 1. Now, kind of, it looks like you can evaluate that just fine, but which one do we know is supposed to be the issue? The 0, because of in the original problem. So I'm going to rewrite this as a limit. I'm going to say the limit as c goes to 0, and I'm not actually going to use 0. I have to use the right bound or left bound, and we got to think about which one I should use.
Well, if you use the right bound, you're using 1.
Yeah, so, well not, but the right bound wouldn't be 1. The right bound would be 0.00000001, like something barely to the right. So does it make sense to go to the left of 0 and go a little bit negative, or go to the right of 0 and go a little bit positive? If you're going from 0 to 1. You're going to go right. You're going to be a little bit positive. Does that make sense how we choose if it's right bound or left bound? So we're going to go just a little bit in the right direction. That's what we're going to do.
If negative 1 is 0, we can choose left bound.
Yes. Yes. So we're doing right bounds, and we're going to do of 3 over 2 x to the 2/3. We're evaluating it from 1 to c. So I've got 3 over 2 times 1 to the 2/3 minus 3 over 2 times c to the 2/3. And what I'm going to use for c, because you can actually type this in your calculator to help you figure out what that would be, is you can use the decimal point 0.00000. You can use as many zeros as you want. We just want a decimal that's slightly above 0. Although, since you can actually plug 0 in there, like that, this right here is not undefined at 0, even though the original integral was. So what do you guys think we're going to get if we plug in 0.00001? Yeah, it's basically going to be 0, not quite, but it's close to 0. So here, if we look at this one, we're going to say we've got 3/2, right? Because if I plug in 1, I get 3/2. Minus 0 equals 3/2. So since those worked, what would our conclusion be? It converges. So the area underneath that curve converges to 3/2. So if you were to type this in your calculator, you would not be able to type in from 0 to 1 and get 3/2. Your calculator would give you an error message. However, if you typed in from 0.00001 to 1, you would probably get, you should get 3/2 as an answer, or not 3/2 exactly, but it's decimal very close to that.
So we couldn't just do that?
Nope, if you type this in your calculator is going to give you an error message.
No, I'm talking about why couldn't we just put it point?
Oh, you could. No, you could. Yeah. So, 0.0001. I guess it depends on how your calculator handles that many decimals. You might have to do less. 1/3 x. See, so I plugged it in my calculator like that, and it gave me something real close to 1.5, but not exactly. You can, it's going to say error. It's going to think for a while, and it's going to say no. It's like really trying. Oh,
Hey, you were wrong.
hey, yeah. Although, well, we ran into this right on one of the problems. It might do it sometimes, but it's not going to do it for you every time. And that is not the actual answer, right? It should be 1.5 exactly.
Close.
It is so close, yeah. All right.